Look up at the night sky. Every star, every nebula, every galaxy visible through the most powerful telescopes, together they account for less than 5% of the universe. The rest lies hidden, invisible, unknown. Scientists have a name for this invisible majority: dark matter. Unlike normal matter, atoms, protons, neutrons, electrons, dark matter does not emit, absorb, or scatter light. It does not reflect sunlight, does not glow in the infrared, does not block starlight. For our eyes, and even for our most sophisticated instruments, it is transparent. But though we cannot see it, we know it must exist. Why? Because of its gravity. The story begins nearly a century ago. In the 1930s, Swiss astronomer Fritz Zwicky was studying the Coma cluster of galaxies. He noticed something strange. The galaxies were moving far too fast to be held together by the gravity of the visible stars alone. By all logic, the cluster should fly apart. Zwicky proposed that some kind of missing mass was holding it together, an unseen substance he called Dunkel materie, dark matter. At first, few believed him. Decades later, in the 1970s, American astronomer Vera Rubin provided decisive evidence. She measured the rotation curves of spiral galaxies like our Milky Way. According to Newton's laws, stars farther from the galactic center should orbit more slowly, just as outer planets in our solar system move slower than inner ones. But Rubin found the opposite. Galaxies rotated as if they were solid disks. Stars at the edges moved just as fast as those near the core. Something unseen was adding mass, creating gravitational glue. That something was dark matter. Since then, evidence has piled up. The cosmic microwave background, the faint afterglow of the Big Bang, shows ripples that only make sense if dark matter was there from the start, seeding the growth of galaxies. Gravitational lensing, light bent by gravity, reveals that galaxy clusters deflect more light than their visible mass allows, again hinting at an invisible halo. Simulations of the universe's evolution fail unless dark matter is included. Without it, galaxies would never have formed. Today, scientists estimate that dark matter makes up about 27% of the total mass energy of the cosmos. Dark energy, an even stranger force driving the expansion of the universe, makes up about 68%. Normal matter, the stars, planets, gas clouds, black holes, and just 5%. In other words, everything we see, everything we touch, everything we know is a cosmic minority. The majority lies beyond sight. And here is the paradox. Billions of dark matter particles are believed to pass through you every second. Right now, as you read this, dark matter is streaming through your body, through Earth, through every star and planet, like a ghost. And yet you cannot feel it. Dark matter does not interact with electromagnetic forces. It does not push, pull, heat, or cool normal matter. Its presence is betrayed only by gravity, the weakest of the four fundamental forces. Scientists have built elaborate experiments to detect it directly, enormous underground detectors filled with liquid xenon, shielded from cosmic rays, waiting for the rare event when a dark matter particle collides with an atomic nucleus. Others search for signals in space, gamma rays from dark matter annihilation, or distortions in cosmic structures. So far, silence. The nature of dark matter remains one of the greatest unsolved mysteries in physics. But let's imagine a twist in reality. Suppose, starting tomorrow, we humans could see dark matter. Our eyes, or perhaps our brains, gain a new faculty, perception tuned not to light, but to this hidden substance. What would happen? The first realization would be staggering. The universe would not look like the delicate scattering of stars we know. It would look like a colossal cosmic web of dark matter filaments stretching across space, with galaxies clinging to them like dew on spider silk. On Earth, we would suddenly see invisible clouds and streams flowing all around us. The everyday world would change forever. But even before that revelation, think of the implications. For the first time, the greatest mystery of modern physics would be visible, immediate, undeniable. Zwicky's missing mass, Rubin's rotation curves, the simulations and lensing maps, no longer mathematical abstractions, but living reality right before our eyes. It is difficult to overstate the impact. Seeing dark matter would be like giving sight to a blind person, not in the sense of recovering what was lost, but in discovering a world that was always there, just hidden. Humanity would never look at the cosmos the same way again. The first night after humanity gains the ability to see dark matter would be the night the sky changes forever. Until now, stargazing has been about points of light, the moon glowing bright, constellations dotting the darkness, perhaps the faint streak of the Milky Way if you're far from city lights. But if dark matter became visible, those points would no longer define the heavens. The entire background of the universe would light up in intricate, ghostly threads, creating a vision at once majestic and overwhelming. What would you actually see? Astronomers already have maps based on simulations and gravitational lensing. These reveal the universe as a cosmic web, an immense structure spanning billions of light years. It's not random. Matter, both dark and ordinary, arranges itself into filaments, long strands like bridges, and nodes where filaments intersect. At these nodes, galaxies cluster by the thousands. If we could see dark matter directly, the night sky would not just show stars scattered on a flat dome. It would show the scaffolding of the cosmos itself. Imagine standing in a desert with a perfectly clear sky. Instead of black emptiness, you would see faint, glowing rivers crossing the heavens like smoke trails frozen in time. These rivers stretch for hundreds of millions of light years. In some places, they intersect in knots, cosmic cities where galaxy clusters reside. And surrounding each galaxy, halos of dark matter would shimmer, cocoons invisible until now, binding the stars within. The scale would defy imagination. A single filament can span more than 300 million light years in length, wider than the gap between our Milky Way and the Andromeda galaxy. On human scales, it's like looking at a spiderweb that stretches across continents, delicate yet unimaginably strong. Astronomers already use supercomputer simulations to predict what this looks like. They start from the nearly uniform conditions of the early universe and let gravity pull matter together over 13.8 billion years. The result, strands of dark matter drawing in gas and dust, where galaxies ignite like lanterns along the filaments. What we would see, if our eyes could perceive dark matter, is this exact architecture, but alive, dynamic, shifting as the universe evolves. In cities, light pollution would still drown out faint stars, but it couldn't drown out the cosmic web. Unlike ordinary starlight, dark matter filaments would stretch across the entire sky, diffuse and persistent. Even in Times Square or Tokyo, people could glance up and see ghostly bands cutting through the haze, reminders that Earth sits within a structure vastly older and larger than human civilization. The psychological impact cannot be overstated. Humanity has gone through revolutions in cosmic perspective before. We learned Earth is not the center of the universe, but orbits the sun. We learned our sun is one of billions in the Milky Way, itself one among trillions of galaxies. Each time, our sense of importance shrank. To actually see the cosmic web would be another step, a realization that galaxies themselves are not independent, but mere ornaments strung along dark matter's frame. Some might find beauty in this, a night sky embroidered with threads of mystery. Others might feel terror. It would no longer be possible to pretend the universe is a cozy place filled with stars. The truth would hang above us, a vast inhuman lattice stretching beyond comprehension. Even art and culture would shift. Imagine painters trying to capture skies crisscrossed with faint veils. Imagine poets writing of threads of night or the skeleton of the cosmos. Filmmakers would render cityscapes where the skyline competes with ghostly arcs above. Religions might adapt symbols of webs, filaments, and nodes to represent divine order. Humanity would reshape its myths to account for what it now sees every night. Yet the wonder would also be practical. By seeing dark matter directly, astronomers could watch galaxies form in real time. They could track how streams of dark matter funnel gas into clusters, feeding star birth. They could test cosmological theories not by inference but by direct observation. It would be as if biologists, after centuries of studying animal tracks, suddenly saw the animals themselves. In short, the sky would cease to be background. It would become a revelation, a constant reminder that the universe is not random but structured, and that structure is now visible. Humanity would look up and, perhaps for the first time, truly see the universe as it is. If the cosmic web in the night sky would reshape our sense of the universe, then the presence of dark matter on Earth would transform how we perceive daily life. Because dark matter is not confined to galaxies and intergalactic filaments, it is here, in our solar system, in our atmosphere, and even streaming through your body at this very moment. If suddenly visible, it would change the way we move, build, and even think. The invisible becomes tangible. Physicists estimate that billions of dark matter particles pass through every square centimeter of Earth every second. Right now, they drift silently through your body, through the walls around you, through the ground beneath you. Normally, they leave no trace. But if humans could see them, the world would take on an entirely new texture. Rooms would no longer feel empty. Instead, they would shimmer faintly with clouds and currents of unseen matter. Streets would appear veiled by ghostly streams, like fog banks that do not scatter light. In forests, between trees, wisps of dark matter would hang suspended, turning familiar landscapes alien. Cities would glow differently at night, not from neon or LED lights, but from diffuse halos of invisible substance pooling between buildings. Walking outside might feel like stepping into a world filled with spirits. You would not be able to touch or move the dark matter. It would pass through you as before, but you would never again experience emptiness. The air, the sky, even the vacuum of space would be crowded with strange forms and shifting masses. Architecture, navigation, and confusion. Our built environments would need to adapt. Imagine working in a skyscraper whose upper floors seem wrapped in ghostly halos of dark matter, or piloting an airplane at 10,000 meters while clouds of invisible mass drift past the cockpit. None of these would physically endanger you. Dark matter does not collide with normal matter, but the psychological confusion could be intense. Pilots might feel like they were flying through phantom storms. Drivers could mistake shimmering clouds for fog or smoke. Even astronauts might feel unnerved seeing halos of dark matter enveloping Earth from orbit. Technology would have to respond. Perhaps augmented reality systems would help distinguish true hazards from harmless dark matter shapes. Architects might design buildings with patterns that align or flow with dark matter currents, making human environments feel more harmonious with the unseen world. Artists might embrace it, turning plazas and parks into open-air galleries where natural dark matter clouds become part of the scenery. The greatest impact might be on the human mind. Our species evolved to see the visible spectrum because it was useful for survival, detecting predators, finding food, navigating terrain. But suddenly adding a new sense, one that reveals a vast and previously hidden world, could cause sensory overload. Some people might develop anxiety or paranoia. Imagine lying in bed and seeing faint streams of dark matter flowing endlessly through your room, never stopping. Or working in an office while wisps of invisible substance pass between colleagues. Insomnia could rise as people struggle to sleep in a world that never looks still. Others, however, might find comfort. Religions might reinterpret dark matter as evidence of a spiritual dimension, the divine fabric of the universe, some might call it. Philosophers might argue that humans, at last, can see the true substance of reality. Artists would certainly embrace it. Painters, poets, musicians composing symphonies about the unseen rivers that flow around us. Children born into this new reality might adapt best. For them, ghostly currents would be normal, just as stars in the sky are normal for us today. Their games, art, and imaginations will weave dark matter seamlessly into human culture. In a few generations, what terrifies adults might inspire children. No cultural institution would be untouched. Some religious groups might claim dark matter is proof of angels, demons, or a spirit world finally revealed. Others might see it as evidence of the unity of creation, a divine framework binding everything together. Yet skeptics would warn of superstition, arguing that dark matter is not mystical but physical. Entire theologies could split or evolve based on how communities interpret the new vision. Rituals might emerge, festivals where people gather to watch the shifting glow of dark matter under moonlight, pilgrimages to places where its currents appear densest, meditation practices that focus not on emptiness but on the ever-present background of invisible matter. A shift in human identity for millennia, humans thought of themselves as living in solid, empty space punctuated by objects. Suddenly, that sense of emptiness would vanish. Life would feel embedded in a dense, interconnected fabric. Humanity would no longer perceive itself as moving through void, but through a medium alive with unseen presence. This could spark new philosophies. Perhaps we would begin to see ourselves less as individuals moving through space and more as threads woven into a universal web. Political movements might harness this vision, some for unity, others for control. Nations might fight over interpretations, while global institutions could push for cooperative exploration of what dark matter means. The mundane becomes strange. Even daily routines would shift. Cooking in your kitchen while ghostly wisps float by. swimming in a pool while dark matter currents swirl invisibly through the water, sitting in traffic and noticing streams flowing between cars. Simple tasks might take on an eerie, otherworldly quality. The world would never again feel ordinary. To see dark matter is to live surrounded by constant reminders that we are small, temporary beings embedded in something far greater. Some might thrive in that awareness, living with awe and humility. Others might struggle, overwhelmed by the endless presence of the invisible made visible. For thousands of years, humanity's progress has been defined by one thing: new ways of seeing. The telescope revealed moons around Jupiter and galaxies beyond our own. The microscope unveiled cells and microbes. The X-ray showed bones inside the body without cutting it open. Every time we expanded vision, a revolution followed. Now imagine the greatest expansion of all, the sudden ability to see dark matter, the invisible substance that makes up more than a quarter of the universe. This would be nothing less than a second scientific renaissance. Astronomy without blindfolds. Until now, astronomers have worked like detectives chasing shadows. They map galaxies, measure velocities, detect gravitational lensing, and run simulations, all to guess the distribution of dark matter. If it became visible, that blindfold would fall away. Every galaxy would appear wrapped in a dark halo, showing exactly how invisible mass holds it together. Scientists could finally solve mysteries about galactic rotation, star formation, and cosmic evolution. They could trace filaments of the cosmic web in real time, watching matter flow like rivers across the universe. Think about it. Right now, the Large Hadron Collider costs billions to search for exotic dark matter particles indirectly. But if we could see it directly, even schoolchildren with backyard telescopes could watch the universe's skeleton glowing in the night sky. Mapping the universe in 3D, the next revolution would be mapping. Today's galaxy surveys already chart billions of light years, but they are limited by visible matter. Add dark matter into the picture, and the universe would reveal itself in stunning 3D detail. Astronomers could map how galaxies align along filaments, how voids form between structures, how entire superclusters connect into a lattice. This map would not just show where matter is, it would show why it is there. In a sense, we would finally see the universe's blueprint. Space exploration would also change. Navigation could account for the invisible landscape of dark matter. If spacecraft could one day interact with it, even slightly, pilots might use dark matter flows like cosmic highways, accelerating travel across space. Particle physics breakthrough. Dark matter is not just structure, it is substance. Physicists believe it could be made of exotic particles, WIMPs, weakly interacting massive particles, axions, or even more bizarre candidates. If visible, researchers could observe how these particles cluster, stream, or scatter, offering direct clues about their nature. This could end decades of mystery in particle physics. Imagine looking at the sky and being able to tell, just by color or shimmer, which type of particle dominates. Some regions might show WIMPs forming halos, while axion fields shimmer elsewhere. Particle accelerators would no longer guess, they could aim experiments precisely at observed behaviors. Entire branches of theoretical physics could leap from speculation to direct evidence. History shows that once humanity sees something, we try to harness it. Electricity was first observed as lightning in the sky. Centuries later, it powers civilization. Radiation was once invisible until Geiger counters clicked. Today, it fuels medicine and nuclear energy. Dark matter, if visible, would be no different. Even if it interacts weakly, visibility would allow us to study patterns and densities, perhaps finding places where it pulls or fluctuates. Could dark matter be harvested as a new energy source? At present, that sounds impossible. But so did nuclear fusion once upon a time. If any interaction exists beyond gravity, humans will find it and exploit it. Engineering might change too. Cities could be designed to align with local flows of dark matter, perhaps stabilizing structures or even tapping subtle energy gradients. Spacecraft might one day sail along dark matter currents the way ships use wind. At first, these are dreams, but so were satellites before 1957. Medicine and biology. Even biology could benefit. Right now, dark matter passes through our bodies unnoticed. If visible, scientists could study whether its presence correlates with subtle biological effects. For example, does dark matter distribution affect cosmic radiation exposure? Could certain regions of space be healthier or more dangerous for human life? Might we design medical detectors that track dark matter streams through tissue, offering new imaging tools beyond X-rays and MRIs? Perhaps this is far-fetched, But remember, X-rays were discovered accidentally in 1895, and within a year they were used to skin broken bones. If dark matter became visible tomorrow, creative scientists would find practical uses within decades. A new age of science education, perhaps the most profound change would be in how ordinary people understand the universe. Right now, cosmology is abstract. Few truly grasp what 27% dark matter means. But if visible, children could look up at the sky and literally see the backbone of the cosmos. Science education would no longer rely on diagrams or animations. Teachers could point to the night sky and say, "That's a filament. That's a halo around a galaxy. That's why Earth exists, because invisible matter pulled normal matter into place." Such visibility could inspire a new generation of scientists, artists, and thinkers. Just as the telescope sparked the scientific revolution, seeing dark matter could ignite a second enlightenment where humanity feels not just curious about the universe, but deeply connected to it. Cautions and responsibility, but revolutions always carry risks. The atomic age brought nuclear power and nuclear weapons. If dark matter hides new physics, new energies, or new ways of manipulating reality, humans will be tempted to weaponize it. Entire nations might race to exploit visible dark matter flows, leading to conflict. The challenge would be balance. Knowledge could unite humanity, offering a common vision of the cosmos. Or it could divide us as countries and corporations fight over who gets to control the invisible made visible. To sum it up, the moment dark matter becomes visible, science as we know it takes a quantum leap. Astronomy becomes transparent. Physics gains a new frontier. Energy and engineering find new possibilities. Medicine gains new eyes. And everyday humans gain a perspective that once belonged only to gods. It will be the dawn of a new age, an age where the universe no longer hides its skeleton and where humanity must decide what to do with its new sight. Dark matter has always been there, flowing through galaxies, surrounding stars, streaming through our own bodies. We've only known it by its shadows, its gravity, its invisible fingerprints on the universe. But if one day we truly saw it, the world would never look the same again. The sky would no longer be empty, but woven with colossal threads of lightless substance. Our daily lives would feel haunted by ghostly flows. Science would leap centuries ahead, unlocking secrets once thought impossible. And yet, the real challenge would not be dark matter itself, but us, how we handle revelation, how we adapt to living in a cosmos more vast and strange than we ever imagined. Would we embrace wonder and unity, or fear and division? That choice, as always, lies not in the stars, but in humanity's hands. If this journey into the unseen universe fascinated you, don't forget to like, share, and subscribe to the channel for more mind-bending what-if explorations. Thanks for watching until the end. See you in the next what-if video.